let's get into it. I'd like to just a quick biography about Kathleen before we get started. So Kathleen's actually at James Cook University and is a PhD student, and her project is all about exploring the wonders of dunes and beach sediment in northeastern Australia. And her research covers a vast area of Queensland from the tip of Cape York to the north, in the north to Bribie Island in the south. Kathleen is really hoping to determine if you can use a single grain of sand to tell a story about plate tectonics. So hailing from South Africa, Kathleen had pursued a master's in geoscience, exploring elephant, white rhino, and warthog wallowing ethology, as well as faunal occurrence at naturally forming waterholes in Shamwari Private Game Reserve. So thanks everyone. I can't really clap, but I'm really excited to hear Kathleen. So I'd like to pass over to Kathleen now and set up your presentation and off you go. So thanks, Kathleen.
Perfect. Thank you so much. Let me just share my screen for everyone. So hello everyone. So before I start, I'd like to just acknowledge country. I acknowledge the Australian Indigenous and Torres Strait Islanders peoples of this nation. I acknowledge the traditional owners of the lands of which I conduct and present my research, and I pay my respects to ancestors and elders past, present, and emerging. So before I dive into my research, I would actually like to ask the audience a question. So if you can go to the little Zoom reactions, I'd like everyone to give a thumbs up if you like going to the beach. I'll give everyone a couple minutes to do that and see if anyone's listening. Yay! So most people love going to the beach, and the Australian coast and its thousands of beaches are an iconic status in the Australian culture and way of life. So why am I talking about beaches? So this actually brings me to my research. So my name is Kathleen Vowles, and I'm currently a PhD candidate at James Cook University. And my research explores the sedimentary provenance and tectonics through detrital zircon geochronology of modern beach and dune sands of northeastern Australia. So in summary, I explore the origin and age of the sand that you stand on some of the most iconic beaches in Queensland. Now that you know what my research focuses on, you can understand why for the past 2 years, every time I see sand, I look like this, an absolute lunatic. Understanding the geologic evolution of complex long-lived geologic terrains is often investigated through provenance analysis of both ancient and modern sedimentary deposits, and the associated tracing of these sediments through the depositional system. So one of the earliest uranium-lead detrital zircon provenance investigations to attempt this approach in Eastern Australia was actually conducted by CIRCOM in 1999. So he investigated the connection between the provenance of modern coastal deposits and the bedrock geology of the immediate hinterland. And this was conducted in southeastern Australia, all the way from Victoria in the south to Fraser Island. So more recent works were conducted by Vevers in 2015. So their work showed that modern beach sands in southeastern Australia are dominated by Neoproterozoic and Paleozoic zircons, which are predominantly sourced from the orogenic belts along the east coast of Australia. However, both of these studies actually ceased at the Queensland border, and the provenance relationship between coastal sediments and the bedrock geology of the northern half of Australia remains largely unknown. Thus, this actually brings me to the aim of my research. So my research aims to seeks to expand on the techno-provenance of beach and dune sands of Eastern Australia initiated by CIRCOM in 1999 by investigating similar detrital zircon provenance north of Fraser Island to the very tip of the Cape York Peninsula. So as you can see on this map, I have a rather large study area. So I've sampled 23 beaches starting from those at Bribie Island in the south over here, all the way to those in the north of Thursday Island. So the aim was actually to sample and analyze those remote and poorly understood beaches and dune deposits. So this led to a grand adventure trying to get to some of the locations, especially those in Cape York. and it required different modes of transportation. So as you can see, ferries, quad bikes, 4x4, and walking many kilometers. Sometimes we had to adhere to really strict schedules to allow for tides. Otherwise we would have ended up like this car. It's not like we didn't try a couple times. Here I am getting bogged in Cape York around Cape Bedford area. Not fun trying to get that out, but folks on 4-wheel drives definitely helped us out there. So the beach sediments were actually collected at the high tide mark of these beaches, which were then prepped at the JCU laboratory. So heavy mineral separation of the samples were undertaken using the Wilfy table. And after this, the zircon grains were handpicked at random and were mounted in epoxy discs, which were then prepped for the laser. The zircons were then dated using uranium-lead laser ablation, inductively coupled with plasma mass spectrometry at the Advanced Analytical Center at James Cook University. Now, hitting these zircons with the laser, the best way I can compare it is to Luke Skywalker using the Force to destroy the Death Star. Now, my favorite part, which is the results, and I find them truly fascinating. So as you can see, these results are quite a lot to take in. So I've divided them into 6 categories to better tell the story of the beach sand's origin. So as you can see, we've got yellow, which is less than 100 million years of age. Orange is 100 to 175. Light green is 225 to 350. Purple is the 350 to 500. Blue is the 500 to 700. And lastly, the oldest age population I'll be talking about is the 1,500 to 1,800 million years of age. So as you can see in this graph, the predominant age population are those highlighted in light green. So these are actually consistent with the New England origin. So this is actually what we expected. So as you can see on this map, the pink represents the New England origin, which has been eroded from the hinterland and transported to the ocean via drainage systems. It is then transported northwards via longshore drift. And this is why we have this New England age population in all our beach samples, including those all the way up through to Cape York. However, as you're moving further away from this origin here in pink, we would actually expect the New England population to be overprinted by other sediment sources in the north. For example, those highlighted in orange of the Mossman origin. Numerous authors have actually proposed that the New England actually extends further north as far as to Papua New Guinea, where igneous rocks of this affinity are actually known. Supporting evidence of this extension was actually derived from detrital zircons of 2 drill cores on the submerged Queensland plateau. Here are our 2 drill cores. These yielded age populations of about 319 and about 298. So this actually suggests that this New England origin extends northwards in the submerged northern Queensland continental margin up through to Papua New Guinea. So this actually makes sense. And with our results, we can see that this New England age population does extend up through Cape York. So it actually confirms the extension of the New England origin along the continental shelf and Queensland plateau north into Cape York, and eventually into Papua New Guinea. Next, we're going to move on to our dark green, which is our oldest age population. So as you can see, these age populations are prominent, as you can see here from Captain Billy's Landing northwards to the tip of Cape York and Somerset Bay and Loyalty Beach. So this actually makes sense because these age grains correlate with those of the Etheridge province, which are highlighted in green here with our cross pattern. However, it is most likely the Cohen India, which is drained into the ocean and transported northwards via longshore drift. Therefore, only the northern sites would have this particular age population. And this is consistent with the findings that I'm getting in my beach sediments. Now we're moving on to the Mesozoic sediments. So this is where the results really become fascinating. So as you can see, the yellow is our youngest age population of grains that are less than 100 million years of age. And this age population can be seen at Captain Billy's Landing, at Whitehaven Beach and Cape Hillsborough, as well as Fraser Island and Rainbow Beach. So these are actually minor Paleogene and early Neogene detrital zircons, which are actually best attributed to sources of the Eastern Australian Volcanic Province, which is also known as the EAVP. So the EAVP is a 3,800 kilometer discontinuous belt of Cenozoic intraplate volcanoes along the entire eastern seaboard of Australia, extending from northern Queensland to southern Tasmania. Now, the EAVP is divided into 4 categories. So you've got your offshore seamount change, which you can see here highlighted in green. You've got your central shield volcanoes, which are highlighted in yellow. You've got your lucitites, which are in orange, and your lava fields, which are in reds. So, however, it's the central volcanoes, these highlighted in yellow, which actually correlate to the detrital zircons that we find in our beach sediments, as they range from about 20 to 35 million years of age. However, the sample that we have at Captain Billy's Landing, I actually suspect is error. As you can see here in the north, so Captain Billy's Landing is about here. We don't have any central volcanoes or of this age range here in Cape York, so I suspect that one is error. However, when we get to Whitehaven Beach and Cape Hillsborough, their age range of about 30 million years of age. And these actually originate from the Mount Jukes-Sinnet complex, which have eroded and then transported to the ocean here via Constant Creek. They then have been transported northwards via Longshore Drift and then finally end up in their final resting places at Cape Hillsborough and Whitehaven Beach. Lastly, we have Fraser Island and Rainbow Beach, which have an age population of about 28 million years of age. And these also originate from the Glasshouse Mountains, and then again are transported northwards via Longshore Drift until they reach their final resting places at Rainbow Beach and Fraser Island. Next, we're going to move on to the blue zone of our Mesozoic sediments. So this age range is about 100 to 130 million years of age. And this is consistent with age ranges according to the Whitsundays Volcanic Province. So firstly, let me give you a little bit of background. So with the Eastern Continental Gondwana and the Jurassic Cretaceous breakup, debates have emerged throughout the years on the tectonics of Eastern Australia during the Mesozoic. One hypothesis, which thought to contain large amounts of colluvial volcanogenic sediment, is the Whitsundays Volcanic Province, and this was thought to be a large igneous province that is silica-dominated and was related to magmatic activity that transpired between 105 and 102 million years ago. Thus, we actually expect to find this presence of these Whitsundays volcanic detrital zircons from Mackay to Whitehaven Beach, and that is what we are getting in our beach sediments. However, we actually find our Whitsundays volcanic province in all our beach samples all the way to the very tip of Cape York. Now, this should not be the case. You would actually expect the concentration of these grains to diminish as they're traveling northwards via longshore drift. So as you're transporting further away from this igneous province, it should be overprinted by other sediments. But as you can see clearly here, this is not what's happening. And you can see that there's peaks in the Whitsundays volcanic province in Cape York, especially here at Cape Bedford. So why is this the case? So this actually brings me to the competing hypothesis to the Whitsundays volcanic province. This is referred to the Tasman arc, as you can see here. So detrital zircon populations of 100 to 175 were actually first discovered in beach stands in southeastern Australia by zircon, which was correlated to Jurassic and Cretaceous volcanism. These Jurassic and Cretaceous sediments have been used as evidence to suggest the presence of a continued subduction and the presence of a magmatic arc system on the margin of northeastern Gondwana during the Jurassic and Cretaceous. So this magnetic chain is hypothesized to spread 2,500 kilometers along the east coastline of Australia, and it extends northwards along the Cape York Peninsula. Recently, this was also supported by additional zircon, uranium, lead, and hafnium data from both tuffs and detrital grains. However, today there is very little igneous bedrock evidence exposed to support the existence of this volcanic arc system, as today it is submerged and rifted in association with opening of the Tasman and Coral Seas during the late Cretaceous. However, in our results, in our beach sand sampling, we can confirm the existence of this Jurassic Cretaceous or arc system offshore along northeastern Queensland. As you can see here, we have presence of about 150 million years of age, which has never been documented in bedrock geology on the mainland of Australia. Therefore, it has to be coming from offshore, and this is related to the Jurassic Cretaceous arc system offshore. So these specific ages have never been documented before. So this brings me back to Brian's theory on the large igneous province of the Whitsundays volcanic province. So Henderson has actually reinterpreted the Whitsundays volcanic province to represent a back arc system. A back arc system rather than a silica igneous province, which is also consistent with the concept of the Jurassic Cretaceous arc system. This is also consistent with my findings where possibly the late Mesozoic arc system formed the Whitsundays extended further north along the continental shelf into the Cape York Peninsula, but currently it is not exposed today. And as you can see, it is highlighted in blue here. So these mid to late Mesozoic magmatic rocks likely existed along the continental shelf, well north of the Whitsundays region, which we can confirm in our beach sediments in northern Queensland up through Cape York. Moreover, these workers have also documented the presence of an onshore component of the continental magmatic arc system, exposed in central Queensland, termed the Moreton Igneous Association. We do find presence of the Moreton Igneous Association in some of our grains, however, very few to actually tell a story. So this aspect of paleogeography of northeastern Gondwana still remains poorly understood, and more so, research is definitely needed to fully understand this development. Now moving on to my dune systems. So dunes sampling analysis was also conducted, and dune samples were taken from the slip face of dunes like this one here. And since this is ongoing research, it's really interesting to determine the beach signatures relative to the dune signatures. So far, our dune signatures are actually consistent with our beach signatures, but as you can see, there is definitely a change in concentrations, especially those of the Etheridge province on the most northerly Cape York samples. However, this brings me to the conclusion of this project, and I just wanted to show you that coastal dunes and beaches represent a fascinating interplay of tectonics with oceanic and atmospheric circulation. That is critical today for understanding the Earth system at a time of significant change. So this shows us that modern sediment shouldn't be overlooked when it comes to provenance investigation. And thank you. That is the end of my presentation. And if you have any questions, I would love to answer them.
Awesome. Thank you so much, Kathleen.
No problem.
I'm going to make this bigger. Here we go. Awesome. Do we have some questions in the audience?
I do.
Yeah.
If I can find my video. Okay, question. All right. That was very interesting.
No
I watched the first time and I like this one even more.
Yeah. Yeah.
I have a question. Have you found a zircon population age that you could not link to any tectonic event?
Yes, I actually did. So there was particular ages just less than 1,000 million years of age and greater than 800. So that specific age range, no idea where they come from. And I also have age ranges that are Archean age, have no idea where they come from either. So still a lot of reading to figure that out, but I just assume that a lot of them is just from recycling of the sediment in the systems.
Yeah, that's very interesting because if you're trying to look for, regularly from mineral exploration point of view, if you have this range of ages and you come up with something that you you know that age range is similar to some major deposits that we know, and you have that zircon in an area that we don't have anything that age around it, you're starting to scratch your head to think, okay,
Yeah.
how did this get here? Was it's recycled? It's something else that we don't know it's there?
Yeah.
You know, that's the main question. It's very, very useful tool. I like it. I'll let somebody else ask some other questions if they have some questions.
No problem.
Yep, so if you've got a question, feel free to pop it in the chat, or if you'd like to come off mute and chuck your video on and ask Kathleen. I probably had a question for you, Kathleen. Is there going to be, what was I say? I guess, you know, is there like a tie-in for some of like understanding the volumes of material that were moved around and stuff? I know you're also looking at the populations. Is there an indicator of how this sort of relates back to some of the work that's going on with sort of movement of sediment load and some of that work that maybe some of the other research groups like Earth Bites are doing, and looking at sort of the plate tectonics and the movement of these coastlines over time?
Yeah, no, that's actually a really good point. So this comes into play more with my coastal dunes paper, because the dune deposits mainly correlate with climatic changes and sea level changes. So those have to be taken into consideration with the development of these dunes in the first place, and actually where the sediment comes from. So that's a huge indicator of the sediment budgets during that time period. Also, when looking at, so Whitehaven Beach, for instance, so that movement of white, the color of the beach is also so white in the first place, there is a climatic variable that's an indicator there that changes the color. So that's also different things that you have to think of. So yes. So in summary, yes. And I'm also doing an additional paper focusing around Princess Charlotte Bay, and showing how at Princess Charlotte Bay, that's a sediment distribution hub, especially of those sediments of the Etheridge province, as you saw in some of my beaches and dune samples, and how it's being transported northwards and is a significant sediment source for all these beaches and dunes in Cape York as well.
That's really interesting. Excellent.
Yeah.
I love it. Oh, I think you've stunned everyone. I think they're just in holiday mode already in the
Probably
audience.
too much information, probably.
No, it's great. It's great.
I have a question, if you don't mind. I did miss the first 10 minutes, so I don't know. Did you do any geochemistry or not around
No.
samples? And with your detrital zircons, were you able to get enough zircons in your study?
Tons.
Zircons?
Absolutely tons of zircons. Tons. Yeah.
You didn't. So how did you confirm that? Because it's, I suppose it can be expensive. So did you use a handheld XRF before choosing your samples, or?
No, so in general, because I wanted to get an age range of every possible zircon I could get so that it wouldn't be biased, I just chose handpicked zircons at random and just ran them through the laser that we have here at James Cook University at the Analytical Centre. And luckily I had grant funding to sponsor running of the zircons, because it is really expensive. I would have done a lot more geochemistry, which I really wanted to do, especially like hafnium data, but just unfortunately didn't have the funds to do so.
So, like I said, I missed the first 10 minutes. Did you actually get rock samples, or were they just?
No, it was all completely sand.
All sand. Okay.
Or
all
unconsolidated sand, yeah.
right.
I got them at the high tide mark, and then on my dunes, I got them on the slip face of the dune. So all unconsolidated sediment.
Okay, thanks.
Yeah, no problem. Any other questions?
I'll pop on mute. Yeah, so go Nadir.
It's not a question, but mostly a comment. Here in the West, the Geological Survey, we are doing a big WA, what's called the WA Passive Seismic Array. It's in the grid. So we were also everywhere they put the passive seismograph, we collect regolith samples. So we have those samples, they are unconsolidated, 50 centimeters maximum depth. We bring them up and we're going to do multi-element geochemistry on that, but we also got the geochronologists excited because they're probably going to do similar sort of thing that you're doing with these regolith samples. And look also for heavy minerals in there, so we can get a grid. So that's interesting to see your work because we'll be copying it.
Oh, you're copying. It's amazing.
Nicely copying it and referencing it.
Well, if you're doing that, if you find some
Thanks.
rutile, so in
Yeah.
my samples, I found a lot of rutile, which you can also do some age dating on, but also again, fundings couldn't do that. So that also yields really important information that you could use.
Yes.
Yeah.
We use it.
Yeah.
Thank you.
Yeah.
Yeah, as a follow-on to that, I know we recently had a master's project that did research on the zircon provenance for the Murray Basin, and it's amazing how far the minerals can move down the river system. So I think we're like obviously on the other drainage divide, but it'd be interesting to sort of go back and have a look at when your papers come out or some of your research and to see what you'll get in your populations, because I think we do have that input down the Great Artesian Basin and Darling River. It's amazing what can actually reach South Australia. Yeah.
Oh, absolutely. Yeah. It's just fascinating. I find it unbelievable, really. I'm very grateful to have done this project. So I didn't expect it to be so fascinating.
I guess I had another question. Like your grains, they're all pretty pristine, aren't they? If you got pretty good grains, like your sand's pretty fresh.
So my last paper, which I still need to do, so bear with me. So I'm doing the zircon morphology as well. So I'm trying to determine how far these specific zircon grains have traveled. And also because they're going through a lot of abrasion as well. But some of my grains, so for instance, at Whitehaven Beach in Cape Hillsborough, some of my zircon grains are beautiful, ehedral, perfect needle-shaped grains, whereas some of my other grains, more towards up north, and some of my offshore samples, they are completely rounded zircon grains, which is interesting. So those are probably like going through different cycles of the sedimentary cycle. So that'd be really interesting. I assume those will be probably my older Tasmanide systems. So it'll be really interesting to see the connection between those.
I have one more question. So the Permian, did you get any Permian zircons?
Yes.
So they would have come from south, and they probably, did you actually get to compare their shapes? So those ones would have been a little bit more rounded.
I haven't done that. That's my last paper, so I still have to do that, unfortunately. But yes, I did get the Permian grains, and it definitely showed that a lot of my beach samples and my dune samples, most of the Permian grains were in my southern samples. So obviously they've transported from South Australia coming up. So there's definitely a link at Fraser Island, that whole disruption of the longshore drift system around there.
So it's like it catches everything coming south.
Yeah. So most of the sediment, when it comes to like Fraser Island, it actually diverts into the Tasman abyssal plain. So there's definitely a transition from sediments from the Hawkesbury sandstone in southeastern Australia compared to those in northeastern Australia. So I'm still trying to find that connection. So I'm doing principal component analysis of all my samples to see that comparison, which will be really interesting.
Okay, thanks.
That's really neat.
Yeah.
Yeah. So that's probably like a big landscape and circulation sort of environmental effect, isn't it, to sort of create those split populations?
Yeah.
Yeah, it just brings to the question, why is Fraser Island there?
Oh, it's because of all that sand
But
that's
why?
coming that way.
Why is piling up there? Couldn't pile up
What's
somewhere else. There's something there that's making they're accumulating there.
That's very true. It's very
Or is it the current is changing or something down the...
I don't know how far the Great Barrier Reef extends down. Maybe, and what could be a factor is probably the width of the continental shelf. That could be a factor in why it's depositing there and the depth. So that's something. And the Great Barrier Reef, those are the two things that are really factors to consider.
Well, it sounds like you picked up like stuff from the Lachlan Fold Belt
Yeah.
the Newfoundland Fold Belt, you know, the magmatic arcs down south,
Yep.
plus some Precambrian detrital zircons as well.
Yeah,
You
I couldn't
mentioned
believe the age range. Sorry?
you mentioned you got a couple that were dated like over 1,000 MA, did you, or not?
Yeah. Yeah.
So that,
So
they would have been Precambrian, like they would have been from the Gondwanan formation.
yes, yeah.
Right. So how many populations did you narrow it down to, a certain number of populations?
So I narrowed it down to about 9 different age populations. So I also picked up the Greenville origin as well, but I didn't talk about it because they were very insignificant. So about 9 age populations. And then I had some that were older than about 2,000 million years of age, but it's really hard to narrow down where those ages come from. And then I have an age peak ranging, as I said previously, between about about maybe 700 to 800 that I have no idea where that age range actually comes from. But very few grains, so not enough to tell a story, unfortunately.
No, okay. Yeah.
Awesome.
Yeah.
I think Kathleen, you've got some papers that are already published, don't you? So maybe we'll have to grab them from you and we can put them in the newsletter if people want to catch up on your work.
To be continued. I'm about to just publish my first
Awesome.
paper on my beach sediments. It should
Well,
come out probably in January or February.
all right. Well,
Hopefully. Yeah.
Nadia's the newsletter editor, so we'll make sure we'll keep in touch and we collect them as they come out.
Okay.
So it'd be great to promote your work. It'd be good. Yeah.
Oh, thank you. Thank you
Yeah.
so much. Yeah.
That's all right.
Yeah.
I don't know. Does anyone have any other last questions? We might let Kathleen have a break now. It's been good. Some good discussion today.
Absolutely.
Yeah. Awesome. All right. Well, I'd like to say thanks, Kat, for coming along today and presenting. It's been really interesting and good to have a bit of time extra to sort of talk about your work afterwards. Because for those at the ARGA Symposium, we had a very tight deadline, so we had to whiz through. It was a big couple of days. So
Yeah.
I really appreciate you coming on here today and presenting your work.
No problem. It's been fantastic.
And thank you for the people that attended, other than
Yes,
going
thank you,
Christmas
everyone.
shopping.
Yes, thank
Yeah.
you.
Yeah, and we'll make sure we get out the invites for the next webinar pretty soon. And for those that are keen to get the newsletter, if you're not already specialist group members, please get in touch. But yeah, please reach out if you've got any webinar suggestions as well, people you'd like to see present, or if you've got perhaps if you're doing research and you'd like to present, please let us know. Great.
And if you haven't yet, follow us in LinkedIn at ARGA, because that's where we advertise everything.
Yeah, we want to
As
try and
we
get that nice and active.
Yes, because we communicate with the community. Right.
Awesome. Thanks, Nadia. All right. Thanks, everyone. Have a great Christmas.